Hello everyone. I wanted to give you a little bit of extra directions for Project 4. So I'm just going to walk through some of the examples with you, but I'll be taking everything that I'm talking about from the directions that I provide for you for Project 4. So remember that in Chapter 6 we're being introduced to the standard normal distribution, right? And so for this project, we're going to use StatCrunch to find different z-scores and probabilities using the standard normal distribution. So there are two different ways that we can find z-scores. We can either use the table that's provided in your textbook. It looks like this. So you guys have this available to you, but I will walk you through how to use technology to find these z-scores. And technology is just going to be more accurate. It'll be a lot easier for you to use than by looking up numbers in these tables. So that's what our project is going to be. So for this project, just go ahead and open StatCrunch. Remember, you're getting to that through your MyMathLab, so you're going to have to log into your MyMathLab account. And then once you get to this page, you can just open StatCrunch from here. We're not using any data sets for this project, so go ahead and open StatCrunch. And then we're going to look at, if I go back to our project directions here, we're going to look at a few examples. So once you get into StatCrunch, go ahead and open, let me go back over here. So click on Stat once you get into StatCrunch, and then we're going to use a calculator. So go down to Calculators, and then since we're talking about the normal distribution, click on Normal, and then that will open our calculator to get the z-scores. So this is our page here that we'll use. You do want to make sure, this is the default setting, so it's probably already in there, but you do want to make sure that your mean is set as 0 and your standard deviation is set as 1, and that just means that this is a standard normal distribution. So you can make sure that that's in there. And then this box down here is where we're going to put in what the z-score is. So if we look at this first example here, it says to enter the desired z-score or the known area or the probability. So remember, we're going to be able to find one of them if we know the other one. And so we'll practice doing it both ways so that you can see what that looks like. And then we also have to set the desired inequality. So remember, if I go back over to our picture here in our graph, we're going to set this inequality as less than if the directions are telling us to find an area either to the left or less than a certain z-score value. If it's asking us to find an area to the right, then we're going to have to set our inequality as greater than or equal to. So just make sure that you're paying attention to that in your directions and in what the example is saying. So let's do this first one together. So it says, for example, if a question is asking you to find the area to the left of z-score 0.44, that means that we're going to put that z-score in the middle box. So I'm going to go back over here. We'll put 0.44 in the middle box, since that's the z-score that we have. And since this one said find the area to the left of that z-score, I'm going to change my inequality sign so that it's less than or equal to, and I haven't even hit compute yet, but it just automatically gave me the answer. So what this means is, if we're finding the probability or the area, which is this red part, this entire area is equal to 0.67, and I know that's a really long decimal because it's giving us the exact or close to the exact value, but you can always just round those. They're typically rounded to 4 decimal points. So when you're doing the exercises on your own, you can just round it to 4 decimal places. So, and if it doesn't give you the answer right away, you can just click compute and then it should pop up there. So the answer for this one for our probability would be 0.67 is our probability to the left, or the area to the left of 0.44. So, okay, let's try another example. So let's say that we're trying to find an area that's between two z-scores. So the first one that we did was just to the left of 0.44, but if we want to find one that's between two z-scores, we'll just click up here on our calculator on between, and see it already kind of gives us an example of what this would look like in the graph. Remember, we're looking for the red area, so that shaded area. And so let's say for this example, we want to find the area between -1 and 1. So if those are our z-scores, this one's actually already in here because this is the default one that's in here, but if you were putting it in, you would put -1 as the smallest value for the z-score. So -1, which is less than or equal to x, which is less than or equal to +1. And when you click compute, that area is 0.68, about 0.6827 if we round that to 4 decimal places. So what that means is about 68% of the area is between a z-score of -1 and the z-score of +1, or within 1 standard deviation of the mean, which is 0 here. So, okay, and then one more thing that we'll look at is if we're asked to find the z-score from a given area or probability. So, remember, on this first example, we started with the z-score, but what if we don't have the z-score? So if they give us the probability, let's say that the area to the right of an unknown z-score is 0.2061. So I'll put in that area. We don't know what the z-score is, so we're just going to put in that number and then change the inequality sign to greater than, since our area is the cumulative area to the right, and then it should go ahead and automatically compute it for you. Or you can click compute and then this should pop up. So this looks like our z-score is going to be 0.82. So it's about right here on our graph, a little less than 1. And that z-score has an area of 0.2061. And that was the number that we started with. We just kind of worked backwards on that one to get the original z-score. Okay, and then the only other thing that you guys are going to see in this exercise is some of the questions are going to be coming from a standard normal distribution, but some of them are not. So if the question is not specify that this is a standard normal distribution, then that means that we're going to have to change our mean and we're going to have to change our standard deviation because they're not going to be 0 and 1. So for example, if you're following along with me in the directions, I'm looking at this last example right here, example D. So this example says that, let's say we have a normally distributed sample of IQ scores, but the mean is 100 and the standard deviation is 15. And we're looking for the percentage of scores that are less than 118. So I know this one says that it's normally distributed, notice that, but it's not the standard normal distribution. So it's okay that it's normally distributed. We can still use our calculator for this, but it has a different mean. The mean is not 0, it's 100. So we just need to put that into our calculator. So let's go back. And we're going to put 100 into our calculator. And our standard deviation, it says in the question that that's 15. And then we need to find the percentage of scores that are less than 118. So I'm going to do less than. And I'm taking this out so we can replace that with what our question's asking. Less than 118. And then click compute. Okay, so it looks like for this one you should get 0.8849. And what that means is, for this example, we were talking about the IQ scores, so for this example, what that means is about 88.49% of the adults in that sample of IQ scores were the ones that had IQ scores that were less than 118. And so our graph is showing us a picture of that. But then that area, this red area underneath the curve, is what that probability is. So this last example kind of gives you an idea of more of what this could look like in a real life example. So I hope this is helpful to you guys. As always, let me know if you have any questions. I think after that, as you're reading through the directions for this project, I think there's about 10 questions that you can practice on your own, and then just submit those in to the Dropbox. Okay, thanks guys.